Welcome back to our annual NeurIPS guide. In this video, we're diving into some of the most noteworthy and impactful papers from this year's conference, giving you a front row seat to the latest developments in AI. Let's kick things off with this paper on graph neural networks, which earned the highest review scores of the conference. The authors identify a unifying mechanism called representation scattering that enhances various contrastive learning algorithms. They propose a new framework that combines this scattering mechanism with a topology-based constraint to improve representation diversity and prevent overscattering. Their benchmarks show state-of-the-art performance, solidifying this as a milestone in graph learning. Next, we have differentiable logic gate networks. These models use a relaxed, differentiable formulation of logic gates to achieve faster, more efficient inference compared to traditional neural networks. By introducing deep logic gate tree convolutions, or pooling, and residual initializations, the authors scaled these networks, achieving 86.29% accuracy on SciFAR 10 using just 61 million logic gates, being 29 times smaller than competing methods. We also wanted to give a shout-out to the Road Less Scheduled, which reimagines optimization by eliminating the need for learning rate schedules, all while maintaining state-of-the-art performance across a variety of tasks. For those that seek alternatives to the transformer architecture, XLSTM introduces two variants to address the limitations of traditional LSTMs. The SLSTM uses scalar memory and exponential gating, while the MLSTM employs matrix memory and a covariance update rule, enabling better parallelization. These models outperform modern alternatives like transformers and state space models, particularly in scaling and efficiency, making them a noteworthy contender in language modeling. Speaking of attention, Flash Attention 3 pushes the envelope with an asynchronous, low-precision mechanism that significantly speeds up attention computations on GPUs. A big step forward for efficient training and inference. Spherical diffusion combines a dynamics-informed diffusion framework with the spherical Fourier neural operator to create highly accurate, physically consistent climate simulations. This model can emulate 100-year climate trajectories at 6 hourly intervals with minimal computational overhead, which marks a major breakthrough in climate modeling, offering stable, high-resolution simulations at a low cost. Another standout is trajectory flow matching, a simulation-free approach for training neural differential equation models. This method excels at clinical time series modeling, offering improved trajectory predictions and better uncertainty quantification. A team from UC Berkeley reframed humanoid control as a next token prediction problem, similar to language modeling. Using a causal transformer trained on diverse sensorimotor datasets, including YouTube videos, they enabled a robot to walk in real-world environments, like the streets of San Francisco, zero shot. On the LLM front, Row 1 snagged a Best Paper award for its selective language modeling approach. By training on the most informative tokens, rather than all tokens, it achieves state-of-the-art performance on benchmarks like math, with significantly fewer pre-training tokens. Special mentions go to SGLang, a system for efficiently programming complex language model workflows, and Buffer of Thoughts, a framework for reasoning that improves accuracy, efficiency, and robustness by storing high-level thought processes. Next, DeepMind's work on many-shot in-context learning demonstrated how to leverage Gemini's expanded context windows to incorporate hundreds or even thousands of examples. Their findings showed significant performance gains across various tasks, introducing techniques like reinforced ICL and unsupervised ICL, highlighting the potential of in-context learning to rival fine-tuning in certain scenarios. Multimodality remains a hot topic, and Cambrian One steps up with a family of vision-centric multimodal large language models. Using their new spatial vision aggregator, the authors bridge the gap between language and vision, achieving state-of-the-art results and releasing a treasure trove of resources for the community. On the image generation front, unlike traditional raster scan token prediction, visual autoregressive modeling uses a coarse-to-fine next-scale prediction approach, outperforming diffusion transformers on metrics like FID while being 20 times faster. Finally, a new method for iterative reasoning optimizes chain-of-thought preferences using a refined DPO loss function with an additional negative log likelihood term. The approach significantly boosts accuracy on reasoning benchmarks like GSM 8K and math, outperforming other Llama 2-based models. That's a wrap on our NeurIPS 2024 highlights. Did we miss a paper you think deserved the spotlight? Let us know in the comments below. Thanks for watching, and as always, enjoy discovery.